Have you ever wondered how the world entered the atomic age and how it changed the course of history? Well, you're in the right place. In today's video, we'll dive deep into the origins of atomic age and explore the events that led to its inception. But before we get started, quick shout out to an amazing book, The Making of the Atomic Bomb by Richard Rhodes. It's a Pulitzer Prize-winning masterpiece on the history and science behind the atomic bomb. And it's a must-have for any science enthusiast. Check out the link in the description below to learn more about this incredible book and get your hands on one today. Now, let's jump into our comprehensive guide on the atomic age. The discovery of radioactivity. In the late 19th century, scientists were making groundbreaking discoveries that would lay the foundation for the atomic age. In 1896, French physicist Henri Becquerel discovered radioactivity while working with uranium salts. This discovery led to further research by scientists like Marie and Pierre Curie, who discovered new radioactive elements such as polonium and radium. Marie Curie's work on radioactivity earned her 2 Nobel Prizes, making her the first person to win the prestigious award twice. Her discoveries not only advanced our understanding of radioactivity, but also paved the way for future research in the field of nuclear physics. Another important figure in the early days of radioactivity research was Ernest Rutherford. In 1899, Rutherford discovered that there were 2 types of radiation, alpha and beta. He also found that radioactive materials decayed over time, releasing radiation in the process. This discovery led to the development of the concept of half-life, which is the time it takes for half of a radioactive substance to decay. The development of atomic theory. As scientists continued to study radioactivity, they began to develop a deeper understanding of atomic structure. In 1911, Ernest Rutherford proposed the nuclear model of the atom, which suggested that atoms have a dense, positively charged nucleus surrounded by negatively charged electrons. This model paved the way for future research on atomic structure and the forces that hold atoms together. Rutherford's work on atomic structure led to the discovery of the proton, a positively charged particle found in the nucleus of an atom. In 1932, his student James Chadwick discovered the neutron, a neutral particle also located in the nucleus. These discoveries helped to refine our understanding of atomic structure and laid the groundwork for future research in nuclear physics. The race for nuclear power. In 1930, scientists were exploring the potential of nuclear power as a new source of energy. In 1938, German physicists Otto Hahn and Fritz Strassmann discovered nuclear fission, the process by which an atomic nucleus splits into smaller parts, releasing a tremendous amount of energy. This discovery sparked a race among nations to harness the power of nuclear fission for both peaceful and military purposes. The potential of nuclear power was not lost on world leaders. In 1939, Albert Einstein and Leo Szilard wrote a letter to President Franklin D. Roosevelt, warning him of the potential for a powerful new weapon based on nuclear fission. This letter prompted the United States to begin research into the development of an atomic bomb, a project that would eventually become known as the Manhattan Project. The Manhattan Project and the atomic bomb. During World War II, the United States launched the top-secret Manhattan Project to develop the world's first atomic bomb. Led by physicist J. Robert Oppenheimer, the project brought together some of the brightest minds in science and engineering. The project's goal was to create a weapon that could harness the immense power of nuclear fission, giving the United States a decisive advantage in the war. The Manhattan Project was a massive undertaking, involving thousands of scientists, engineers, and support personnel working at secret facilities across the United States. The project's main research sites were located in Los Alamos, New Mexico, Oak Ridge, Tennessee, Hanford, and Washington. These facilities were responsible for developing the technology and materials needed to create an atomic bomb. In 1945, the project successfully tested the first atomic bomb in New Mexico in an event known as the Trinity Test. The explosion released an enormous amount of energy, equivalent to the detonation of 20,000 tons of TNT. The success of the Trinity Test marked a turning point in the development of nuclear weapons and signaled the beginning of the atomic age. Later that year, the United States dropped atomic bombs on the Japanese cities of Hiroshima and Nagasaki, effectively ending the war. The bombings killed an estimated 200,000 people, most of them civilians, and left a lasting impact on the world. The destructive power of the atomic bomb demonstrated the potential of nuclear technology, both as a weapon and as a source of energy. The dawn of the nuclear age. The bombings of Hiroshima and Nagasaki marked the beginning of the atomic age, a period characterized by rapid advancements in nuclear technology and the proliferation of nuclear weapons. The Cold War between the United States and the Soviet Union saw both nations stockpiling nuclear weapons, leading to an arms race and heightened global tensions. The threat of nuclear war loomed large during the Cold War, as both the United States and the Soviet Union developed increasingly powerful and sophisticated weapons. The Cuban Missile Crisis in 1962 brought the world to the brink of nuclear war, as the United States and the Soviet Union faced off over the placement of nuclear missiles in Cuba. The crisis was eventually resolved peacefully, but it served as a stark reminder of the potential consequences of nuclear conflict. Throughout the Cold War, efforts were made to control the spread of nuclear weapons and reduce the risk of nuclear war. In 1968, the Treaty on the Non-Proliferation of Nuclear Weapons, NPT, was signed, with the goal of preventing the spread of nuclear weapons and promoting the peaceful use of nuclear technology. The treaty has been signed by 191 countries, making it one of the most widely supported arms control agreements in history. The push for nuclear energy. Despite the destructive power of nuclear weapons, the atomic age also brought about the development of nuclear energy for peaceful purposes. In 1950, the United States and other countries began building nuclear power plants to generate electricity, providing a new source of clean and efficient energy. The first commercial nuclear power plant was opened in the United States in 1958, and many more followed suit. By the time of 1970, nuclear power had become an important source of electricity in many countries, including the United States, France, and Japan. The growth of nuclear power was driven by the promise of clean, abundant energy, as well as concerns about the environmental impact of fossil fuels. However, the development of nuclear power has not been without its challenges. The 1979 Three Mile Island accident in the United States and the 1986 Chernobyl disaster in the Soviet Union raised concerns about the safety of nuclear power plants and the potential for catastrophic accidents. These incidents led to increased regulation and oversight of the nuclear industry, as well as a slowdown in the construction of new nuclear power plants. The future of the atomic age. Today, the world continues to grapple with the complex legacy of the atomic age. While nuclear power has the potential to provide clean energy and reduce greenhouse gas emissions, concerns about nuclear accidents and the disposal of radioactive waste remain. As we look to the future, it's crucial that we continue to explore the potential benefits and risks of nuclear technology. New developments in nuclear technology, such as small modular reactors and advanced reactor designs, offer the promise of safer, more efficient nuclear power. These technologies could help to address some of the concerns associated with traditional nuclear power plants, making nuclear energy a more attractive option for meeting the world's growing energy needs. At the same time, efforts to reduce the risk of nuclear conflict and promote disarmament continue. The 2015 Iran nuclear deal, formerly known as the Joint Comprehensive Plan of Action, was an important step in limiting Iran's nuclear program and reducing the risk of nuclear proliferation in the Middle East. While the future of the deal remains uncertain, it serves as an example of the potential for diplomacy and cooperation in addressing nuclear challenges. With that said, thanks for watching our comprehensive guide on the atomic age. Don't forget to check out the book, The Making of the Atomic Bomb by Richard Rhodes. Be sure to subscribe to our channel for more engaging content, and until next time, stay curious.